This is part 1 of section 2.6, other types of equations. And we're going to start with the power property and solving equations with radicals in them. So the first thing we want to talk about is that we can raise both sides of an equation to some power n. And what we're not saying is that that is equal to our original equation, P equal to Q, let's say. But we do have every solution of our equation in the solution of this new equation that we've created. We do, however, when we raise both sides to some positive integer n, that power, we do have to check all proposed solutions. And it's really important. You will find solutions that don't work. So when we do raise both sides of an equation to a power, we must check all of our proposed solutions. Okay? We do need to be careful doing this, that these equations, P equal to Q, and then the equation that we created by raising both sides of the equation to some power n, are equivalent. They are not equivalent. It only says that each solution of the original equation is also a solution of the new equation. I didn't mention here that this n power that we raise both sides to is the index. I think I mentioned it down here in our steps. But if we have square roots on both sides of the equation, we will square both sides. If we have cube roots, we will cube both sides. Okay? So how are we going to do this? We are going to first isolate the radical on one side of the equation. Everything else goes on the other side. We'll raise each side of the equation to a power. There it is, the same as the index of the radical. And that will eliminate the radical. Now, if you have two radicals, get them on opposite sides of the equation, and you will do this process twice. Let's go ahead and begin. We will start with solving x minus root 4x plus 12 equals to 0. We just said we needed to isolate that radical, so I will add root 4x plus 12 to both sides. Now, since this is a square root, we will square both sides. And now what we have is x squared equals 4x plus 12. Now, since we have both an x squared and an x term, everything needs to come to one side of the equation, and it needs to be set equal to 0. So we end up with x squared minus 4x minus 12 equals 0. And that's a quick factor since that has a leading coefficient of 1. And it's x minus 6 multiplied by x plus 2 equal to 0. So either x minus 6 equals 0 using our 0 factor property, or x plus 2 equals 0. So x is equal to 6 or x is equal to negative 2. Now, we do need to check these. We can go somewhere else on our paper, and I'm going to show you something neat on the calculator. This one's a little simple, so maybe we don't need it. We're going to check x equal to 6. We're going to check that solution. So we're going into our original equation. That's this one. So everywhere there's an x, we're going to put a 6. 6 minus root 4 times 6 plus 12. And we're going to check and see if that's equal to 0. 6 minus the square root of 24 plus 12. 6 minus the square root of 36. It looks like 6 minus 6 equals 0. 0 equals 0. Check. We have ourselves a solution. Now, how about x? We're going to check, and this one I'll do by hand, and the next one I'll show you how to do checks on your calculator. So we have a negative 2 minus the square root of 4 times negative 2 plus 12 equal to 0. Negative 2 minus Root negative 8 plus 12, is that equal to 0? Negative 2 minus root 4. Negative 2 minus 2, not looking too good. Negative 4 is not equal to 0. Okay, so what do? We throw this solution out. Now, let's go and look at number 2. So we only have one solution. I want to make sure I mentioned that we always go back into our original equation. That's where we check those. Oh, I wrote it right here. So check each proposed solution in the original. It can't be one of these that you've manipulated or changed up. It has to be the one that you started with. Now, what do you notice in number 2? In number 2, we have a radical on each side of the equation. We will need to isolate those, not isolate it, but have one on each side of the equation. And we have x plus 4 plus 1. We are ready to square both sides. And this one is just 3x plus 1. Now the other side of the equation is a different story. This is root x plus 4 plus 1 multiplied by root x plus 4 plus 1. Keep that 3x plus 1 there. And let's FOIL. The f of FOIL is just x plus 4. The outer and the inner are both 1 times root x plus 4. So we have 2 root x plus 4. And last of FOIL is plus 1. Now what do you notice? We have another root. So we actually have to simplify this and isolate that on one side of the equation. The first thing I'm going to do is subtract 1 from both sides. The next thing is subtract x from both sides. And now I'm going to subtract 4. And as you can see, we need to divide everything by 2. And we have finally isolated that root. Okay. We'll go to the top here. And we end up with x minus 2 equals root x plus 4. And you guessed it, we're going to square both sides. And we get x minus 2 multiplied by x minus 2 equals x plus 4. So putting this together, we'll have x squared for first of FOIL. Outer and inner are both negative 2x. So we end up with a negative 4x. Plus 4 equals x plus 4. Let's subtract 4 from both sides. And now I can subtract an x from both sides. Let's factor an x out. And here we have our zero factor property that we learned. And either x is equal to 0 or x minus 5 equals 0. So I'm going to circle these proposed solutions since I have a lot written here. And now I'm going to show you how to do this on a calculator. These really aren't that difficult. These are pretty fast. But sometimes it's easier to show students things on a calculator. It's a little bit quicker. So see if I can bring this over here. Make it about like that. So we're back in our original equation. Now, let's go ahead and first check x equal to 0. I'm just going to write check there while I'm doing it. So we're going into our original equation. So I want to go ahead and find the root, second square root. Before I do that, I think I'll show you this. We're going to check x equal to 0. So I want you to put a 0 in your calculator and then press store and then press X. Yes, I'm serious. And then press enter. So now every time you press X, you're going to have a 0. Yes, your calculator has now stored 0 as your x. Don't worry, when you put it in function mode, it'll be cleared. But why did I show you that? Because now watch what happens. X is 0 and we're going to plug it in. You can just type right away. So the square root of 3x plus 1 come out of that root minus the square root of x plus 4. And let's see if that's equal to 1. Now that is equal to -1. So we have to throw that out. Okay? And I'll get rid of this check here. So we checked this on our calculator. I hope you liked that method. Now, this is where it really gets good. Watch this. Now I'm going to type in a 5. I'm going to press the store button. And I'm going to store 5 as x. Now typing, so now every time I press x, I'm going to have a 5. And typing that root equation was a lot of work, so I'm going to go up and grab it and now press enter. And it just plugged 5 into that equation because it now thinks x is 5. And we got 1. And 1 is not equal. Oh, excuse me, 1 is equal to 1. That's what we were wanting it to equal to. So x equal to 5 is a solution. So we wanted that root to equal 1. So I hope you like that check. I will bring that back up here shortly to check our next solutions that we get. Now this is, we have 2 cube roots. Let's see what we have. We do need to put 1 cube root on one side of the equation and the other on the other. So we have the cube root of 5x squared minus 12x plus 6 is equal to the cube root of x. Let's go ahead and cube both sides. The index is 3, so we raise. Oh, how about this? So cube both sides. Okay, so what do we have now? Well, the cube root, when it's cubed, it just leaves what's under that root equals x. That turned out really nice. So let's bring that x over. We're going to subtract x from both sides. And now let's do a little bit of factoring. If we have 5 times 6 is 30, negative 13 goes here. I immediately think of a 10 and a 3. So I have a negative 10 and a negative 3. When I multiply those together, I get a positive 30. When I have negative 10 minus 3, I get a negative 13. I right away plan on rewriting that term and creating a group, 5x squared minus 10x minus 3x plus 6. Now, I'm not using any equal signs down here. This is just my little work area. But what I highlighted, these are equal to each other. So I didn't change the problem. Okay, let's factor out of 5x. We have an x minus 2. Factor out a negative 3 and an x minus 2. We end up with x minus 2 multiplied by 5x minus 3. I want to make note, in factoring by grouping, we actually went from 4 terms to 2 terms to yes, 1 term. This is 1 term. There's no plus and minuses. This is a term and this is a term. And every one of these is a term. So factoring by grouping takes us from 4 terms to 2 terms to 1 term. Okay, let's keep going. We now have x minus 2 multiplied by 5x minus 3 equals 0. So either x minus 2 equals 0 or 5x minus 3 equals 0, or they both could be equal to 0. So x is equal to 2, or x is equal to 3/5. Now you're going to be very happy that we have the calculator when we check both of those. So I'm going to just make a note so that we check both of those, and let's begin with x equal to 2. And we'll have 2 and store it as x. And now we'll just type it in. So math, number 4. In my calculator, it's number 4. So you just type it in, 5x squared minus 12x plus 6. Come out of that cube root minus the cube root of x. And let's see if that's equal to 0. It is. Now, this is the cool part. We did check x equal to 2, and it is a solution. So what I want you to remember is we don't have to retype that. We can now put 3/5 in our calculator. It's going to come out as a decimal in my calculator, maybe not in yours. And then press store as x, enter. Now the calculator has 3/5 stored in its memory. Go back up and get this, and now press enter. Now, I will tell you, this is an approximation for 0. Your calculator may not do that. I just have a simulator here on my iPad, but this is 0.0000, 15 zeros and then a 3. So this is the calculator's approximation for 0, and yes, we do have another solution, and it's x equal to 3/5. That concludes this video.